Hello and welcome to C#. This is class session number 4, so week 4, and this is our Thursday night class. Tonight we've got Nelson and Gavin and myself, Jason. So, yeah, welcome everyone, and welcome to those of you that are new that are joining into the class for the very first time. And today is March the 22nd, 2012. So tonight we're going to be talking about methods. So we're going to look at an introduction to methods, what methods are. We're going to look at method names, parameters, return types. We're going to be talking about all sorts of good stuff dealing with methods. We'll be also looking at calling methods. From this, of course, we'll be able to discuss return, finally, for those of you that don't yet understand the return keyword. And we're also going to talk about local scope. So basically local variables and scope. And then finally, method overloading. So tonight is really a night all about methods. And a quick shout out to those of you that were able to join us last night in the C# Open Office Hours session. It was nice having you guys. We had, for those of you that did not join in, we're getting a lot of people that are becoming much more comfortable with us jumping over to their screens and helping them out. I would like to throw out real quick for those of you that do enjoy getting help like that, please try to invest in a microphone and a headset. That would be absolutely awesome because it does get a little difficult from time to time trying to help those that have to type everything into the keyboard as opposed to just being able to talk with us. So with that, Nelson, let's get things going. Methods.
Methods.
Yeah.
Methods. Let's talk about methods. Let's open up a new console application and talk about methods. Eventually.
You just reboot it, so come on, everything should be nice and fast.
Okay, so methods. What's a method? Well, we have a method right here. We've been talking about static void main, and it is a method, and we're going to be talking about how you can create your own methods. Basically, thus far, we've been working in the static void main method, which is our entry point to our application. So this is where execution begins, and you'll notice how you can do lines like that get executed linearly. You can do lines like that get executed, sequentially inside of a loop, and so on and so on. So we've learned a bunch of different ways that we can populate methods with executable code. But the C# programming language, and pretty much every programming language, allows you to create your own methods. The reason you might want to do that is to take repetitive code and store and place it into another block of code that can be invoked multiple times. Methods are also useful, or rather creating your own methods are very useful when it comes to having large programs. So for example, let's say we have something like this. We want the user to be able to, well, actually I'm going to back up. I'm just going to make a very simple method. Very simple method. Okay, so you'll notice that I went ahead and I added some lines of code here in line 14 through 17 that look very familiar to the lines 10 through 12 that you should be relatively familiar with up until this point. Every program is going to have a static void main in it. But I went ahead and I added a new method. And the anatomy of a method is very important. What you have at the top is your signature. This is what your method this describes what how to invoke your method, what your method can potentially do, as well as a few other things. You always start off with your modifiers. So to begin a method, you first of all have to make sure you're outside of any other method. You cannot write a method inside of another method, at least not using this syntax. And you have to make sure that you're inside of a type. Now remember that methods are the blocks of code that allow you to insert executable or the blocks that allow you to insert executable code. All executable code you are going to write, or virtually all of it, is going to be in a method of some sort. So methods are the unit in which you place executable code inside. And they exist underneath types. So our type here, class program, has now two methods, main and add. And main and add are virtually, this is entirely true, but virtually the only place that you're going to put executable logic inside of these two blocks. If I were to do something like this, that's not even going to, IntelliSense is going to freak out. This is not valid C#. If I were to do this, this is not valid C#. So it's very important to realize that a method cannot be within another method, but must be in a type. In some languages, this is valid code, but not in C#. So if you're familiar with C++, then you just can't, make, in C++ they call them functions when they're outside of methods, but you cannot do that same sort of thing in C#. They must be within types. So I'm going to go ahead and write some code inside my add method. It's going to be very straightforward. We're going to say int left equals int.parse console read line. Int right equals int.parse console read line. And I guess I can put a prompt up there too. Okay, so now I have a method that contains some logic that we can execute. If I were to hit F5 at this point, though, we would get nothing. Even if I were to go ahead and add a console read key onto line 12, we will also have nothing, well, except for the execution halting. So you'll notice that by default, when we define a method, nothing actually executes. What we have to do is we have to invoke this method. And there's a variety of ways that we can invoke this method. Remember that method invocations are going to be the method name followed by parentheses that contain the arguments we pass into the method. Our user-defined methods are no different. So the first thing we have to do is we have to reference this add method somehow. Now, if we wanted to write it out longhand, we could say console application1.program.add. This is an example of invoking the method, and we are specifying exactly where that method is. We are saying console application1 is the namespace, program is the type, and add is the method, followed by parentheses which tell the C# compiler that we want to invoke the method. If I were to run this now, we would actually get, what's going to happen is the execution is going to jump from line 12 all the way onto line 19, and it's going to continue inside of this method sequentially, just like it did in main. So it'll start on line 19, then to 20, then to 22, 23, 25. Once it reaches the end of this, execution is actually going to jump back to whoever called this method to begin with. So we can go ahead and run our little program right there, and we get that result.
And that'd be just like doing system.console.read key.
Yes, that would be like that. And there's actually, because of where we are located, this information is redundant. The reason it's redundant is we are already in the namespace console application 1, so we don't need to use it. We could simply do program.add. That would invoke the same method. Furthermore, because we are in the type of program already, the C# compiler can further infer what members we want to access when working in methods of this inside this type. So we can simply write add. All three of these lines will invoke the exact same method. So I'll go ahead and nuke those out real quickly, and we have basically a straightforward program that on line 12, we enter the add method. So we take execution and we jump all the way onto line 19. Then we continue to execute this method until it returns. I do want to point out for all the C and C++ people, as well as people who might have used dynamic languages in the past, that C# does not require any form of forward declaration. What I mean by that is the add method can be defined anywhere in the code file, regardless of where it's invoked. So I can define this method above or below main. I could define this method in another file. It is irrelevant. The C# compiler does not require forward declaration of any sort. So that's a very nice thing compared to other languages.
So let's go ahead and do some ready checks. Let's have everybody type this out. Except go ahead and make read key back to just a simple, method call, since we are using the namespace.
We did have a question about namespaces, though.
Well, yeah, but that's what I'm saying. Before you start answering questions, go ahead and hit the reset.
Yeah, I already did.
Okay.
All
right.
I guess people were already ready.
So for those of you that are going to follow along tonight, go ahead and make sure you click the participate button in BuzzNet and type this out. Once it's done, hit ready. All right, now we can start with answering questions. Nelson?
Jason?
I thought you had some questions to answer about namespaces.
Oh, I thought you said to...
I said now we can...
Okay. Okay, so the question came in from Alexander. Can you have multiple classes in a namespace? The answer to that question is yes. We aren't going to branch out into having multiple classes even within a project until the final week. But the answer is yes, you can have multiple classes inside of a namespace. I mean, if you were to look at the system collections generic namespace, for example, you'll see a variety of types, such as the list type, dictionary type, linked list type, hash set type, and so on.
Logically, if it only was a one-to-one correspondence, you wouldn't need classes as a thing. You just have namespaces with methods in.
Yeah, or alternatively, you wouldn't even need namespaces. You just have nested classes.
For those of you that are coming in late, do not run the BuzzNet executable application. Go to buzznet.3dbuzz.com in your web browser. Gavin, could you type that over as an answer and submit it in the question panel, newest question?
Right, yeah.
Wick asked a question in the BuzzNet chat, which he should have asked in the webinar question panel, but I fortunately saw it, so I'll answer it. Wick asked, I assume you could have multiple namespaces in a project, but why would you? And the answer is, well, many reasons, just like what Segfault said. Generally speaking, when you get to a large application, you might want to start separating your individual code files into folders, for example. A folder will generally correspond to a new namespace. You'll generally have a root namespace for your project. In this case, it's console application 1. That, by convention, will be the same name as the project name. But underneath that namespace, you might have a variety of namespaces for quite a few different reasons.
Organization is one of the best reasons. Okay, so once again, for those of you that are following along, please make sure to hit the finished once you have, or the ready once you've got things caught up. There we go. Everybody's almost with us. Outstanding. And for those of you that are not participating, come on, participate. Toastage. Yeah, that's right. You toastage.
And definitely, if anybody... were you bumping me?
No, toastage.
Oh. And if anybody has any questions about what is up on the screen right now, you can go ahead and ask them. I'm going to be talking about static and void and the parentheses that follow the add method very shortly. But if anything else is confusing, then definitely throw a question up.
Well, try this real quick, everyone. For those of you that really are new to methods, try creating a new method just using what you see on Nelson's screen right now. Call the method something like say hi. And inside the method, just simply have it do a console.write and have it say hi or have it say something. And then call that method from main. So give that a try. For those of you that are truly new, let me see you set your participate button to 1 minute. Those I see, change it over to 1 minute, please. I'll know that you're trying this real quick. All right, very cool. Outstanding. So real quick, and then I'll have, so this is your first attempt using what Nelson has written to the screen, just to serve as sort of like a template that you can follow in writing your own method. Again, call it say hi. And then when you call upon the method, when you invoke the method, as Nelson is doing in line or on line 12, he's invoking the add method right there. So make sure you invoke your method, say hi. So did you get that, Tom?
Here comes Tom.
And go ahead and make sure to set it back over to ready once you've got this typed out. So it should be a very, very, very small method. Hello, Buzz. Well, hello there.
This does not make the spec. You're fired.
Okay, I have no idea. Where's the mute button?
That was me doing Segfault.
That is not what Segfault. Oi! I beat you that time, Segfault. Okay. So everybody's just about got it. Meta, how are we doing over there? All right. So, Nelson, go ahead and type out that very simple example.
Do you specify the method name?
Yeah, say hi. And see, now he's declared the method. Now he needs to invoke it. Actually have it do something.
Yep. And so if I run this program, you will see hi being written right up there. Okay. So does anybody have any questions about methods so far? Any method questions?
Now,
questions about methods?
Before we move into anything else in regards to like parameters or anything like that, Nelson, let's go ahead and talk about invoking. Where can you invoke a method from? So we're invoking right now from inside of main.
Right. Well, you can invoke a method anywhere that you can access that method, and you can enter executable code. Invoking a method is executable code. I want to make that distinction really quickly here. These using statements are not executable code. This namespace declaration is not executable code. This class program definition is not executable code. This static void main method header, definition, is not executable code. Everything inside of here is executable code. So again, this is not executable code, neither is that. But when we have executable code, we can perform a bunch of different options, or a bunch of different operations, such as conditionals or looping or switches. But we can also invoke methods. And we've already seen how we can invoke methods inside of main with console.read key. We can do this exact same thing with the say hi method and the add method. We can invoke them simply by identifying them by their name and then invoking them using the parenthesis syntax. Was that what you're...
Yeah, well, that, and then also like from within say hi, you can call add. From within add,
sure.
you can...
Yeah, because both of these blocks are executable code, just like main is. They have the same capabilities as main. So say hi could invoke add.
And add could turn around and invoke say hi.
Yeah, but that would
no. I'm glad you did that because Wick asked
that.
Wick asked the question a second ago about can you call, for instance, say hi from inside of say hi. Now,
in this, didn't ask it in the webinar question panel.
No, we were just arguing about it in buzzing.
They were just chatting. I happened to see it. So, which is interesting. We're not going to start talking about recursion, and we're definitely. But go ahead.
You could do this.
Yes.
But Wick, what do you think this code's going to do?
There's a lot of squeaky handling noise coming from you today, Nelson.
Loop endlessly. Did you see that, Nelson? That's his answer.
Yeah. Well, yeah, actually. And then it gets Stack Overflow exception. We're not going to be talking about the call stack, but yeah.
But yes, you can do it, and there are times when it's actually important to do it. Not in any case that we've got going on right here, but you're going to see how we can exit out of methods tonight forcefully by returning back out early.
So somebody else asked, can you put inside loopers? Can you put inside loopers? I know what you're trying to say.
Yes, he speaks English.
Yes, you can invoke methods everywhere inside of executable code. So if I were to run this, you'll see hi being printed that many times. And we can even go ahead and put inside a loop. You can even put inside an if statement. We can even put inside a switch statement. We could even put it inside of a switch statement instead of a while statement. So yeah, you can place method invocations anywhere that you can put executable code. As far as running this, it's just going to loop hi endlessly because of that while true. But still. The point is that you can invoke methods anywhere inside of a method. A method can invoke methods.
Okay, so any questions so far?
Hi, Jason.
Hey, how's it going, Nelson?
Okay, they asked about static and void. That's definitely what we're going to
Yeah, we're getting to those. We're just building our way up. So basically, just real quick, let me just throw this in there. So for our complete beginners, basically a method is nothing more than just a snippet of code, just a little bit of code that is going to perform a very specific set of logic, a very specific task. And you're going to give that method some sort of name that is descriptive for the task in which it is performing. For instance, Nelson has a method on line 34 that says add, but it doesn't really make sense in the context here because add what? But in a minute we're going to be talking about parameters, and we'll make the add method make much more sense. Well, I mean, it does in a sense in the fact that you ask for the numbers right now, but it'll make more sense in a minute when we actually have it take some information in. Because add should just add numbers. Right now, the responsibility of the add method goes a little bit beyond adding numbers. It's also responsible, if you think about it, for interacting with the user and collecting those numbers. And that kind of makes the add method a little bloated.
Yeah.
So we really want to keep our methods concise, doing exactly what they need to do and nothing extra. That's important. And now, for those of you that are, again, new to coding and you're new to methods, so now you understand that methods are nothing more than just kind of like a named task. And we can relate that into the real world with tasks that we've been programmed with. For instance, my kids. And I've used this example before in classes and VTMs. My kids have been programmed to wash dishes. They know how to wash dishes. And I can invoke that bit of logic within both of my girls by saying, Heather, wash dishes. And let's say she's in the middle of watching TV. I tell her that. She's going to get up, go in there, wash dishes. And I, being the person who invoked her going to wash dishes, I don't have to know anything about washing the dishes. I just know the outcome. I need dishes to get washed. I don't care how she goes about doing it as long as it's done properly. So I tell her to go wash dishes. And I remember a long time ago in the Renaissance Center when Zach was in my Maya I-12 class, it was great because I was using this as an example about tasks and explaining how people were programmed. And I asked Zach to go get me some coffee. And he said, okay, got up and started walking out the door. And I said, whoa, 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 whoa. Okay, I was just kidding. He still gets irritated about that to this very day. But the point was very clear. I was able to invoke that action by calling upon a simple name. Go get some coffee. So if you think of methods as just kind of like a black box that you can call upon to do something, and then the code that is inside that black box, if you will, is code that is specific to whatever the name of that method is. So it's specific code for doing something specific. Line 29 declares a method, say hi. And what does it do? It says hi. So that makes sense. Add, I'm sure it adds 2 numbers, but there's a little bit of stuff in there that shouldn't be there when you start becoming a more serious developer. So anyways, I just wanted to throw that out as a little bit of extra help for those that are new to methods and just trying to get their head wrapped around the concept.
Alrighty.
Yeah. So from here, do we want to go ahead and start talking about parameters?
Yeah. Well, I kind of did want to break down this sort of...
Oh, well, at least start with static. And that's just something they have to accept for now.
Yeah, okay. Every single method that you will define inside of your class program until you understand how to do this otherwise, which will happen in week 6, I believe, you must add the static modifier to the method. Now, you can get away with not adding the static modifier to the method just fine until you actually go to try to invoke the method. That case, the compiler will throw an error. It'll say object blah, blah, blah. So when you see an error like this, be sure to go ahead and add the static modifier to the method. Otherwise, you will not be able to invoke it from main. You'll be able to define it just fine. It'll be able to call other static methods, but you won't be able to invoke it from main. So static, just take that for granted for now. The void bit is going to be what that method returns. And we're going to be talking about what methods return here shortly, but right now this just means this method returns nothing. If you remember, for example, if we invoke the string input equals console.readLine method, notice how we're assigning a variable to a method invocation. That's valid because readLine returns a string. If we look at its signature, we see string console.readLine and then empty parentheses. So because this method returns a string, we can assign it to a string variable. Because this method returns a void, which means nothing, we cannot assign it to an anything variable. Immediately after so you have your modifiers, and just place static on all your methods for now. There are other modifiers as well that we'll be talking about later. Followed by the return type. Void means it returns nothing. It is invalid to assign a variable to the result of say hi. If I were to try to do so, I would get an error. It would say cannot implicitly convert type of void to int. So there's no way to assign a variable to the result of a method invocation that returns void. After the return type, we have the identifier, and the identifier is going to be the name of the method. Now, as far as naming conventions go, methods should start with an uppercase character, just like classes, just like namespaces. There really aren't any exceptions to that as far as the standard naming conventions in the C# language go. All methods will be this case. Now, after that, so we have our modifiers, we have a return type, we have our name. There's one more thing we can do to this method. There's one more thing we can do in this method definition. And that is going to be allowing the method to take in information from an outside source. Now, this is a very, very important concept because methods on their own, without a return type and without any parameters, it's not technically impossible, but it's not going to be possible for you right now to have the results of a method be different every time you invoke it. Because if you're not returning anything and you're not taking anything in, there's no way for the behavior of the method to work differently. Now, somebody did ask a question about scoping, as far as, well, couldn't you just do this? Int left equals 4, int right equals 10, and then invoke add, and then have add say, well, I would just remove all this code and simply say console.writeLine left plus the literal plus right plus the literal equals plus left plus right, and you'll notice that I get an error. There's no way for this method to get variables or local variables from other methods that invoke it. But this is very useful. The concept of allowing the method to take in information, to get particular parameters as far as how it should function is very important and pretty much fundamental to writing clean code or abstracting your code into methods, because then you can have your methods perform different actions under different scenarios. Now, it'll still, of course, I mean, maybe I worded that incorrectly. It'll still perform the same actions, but it'll return different values. For example, this add method, we could say that the responsibility of the add method in this sense is to take in 2 integers and then print the results of adding them to the screen. So what can we do? Well, inside of these parentheses, we can add a list of comma-separated type and identifiers. So we can do that. This is adding a parameter to the method. This method now, as the way it's currently defined, says that this is a static void add method that will accept a single integer. Now, the name isn't important as far as the caller code is concerned, but the name is very important when you consider how to reference this data from within the method in the future. This int left is treated like a local variable, except for it's not a local variable we set a value of. It's a local variable that whoever invoked this method set a value of. But you see that our code still doesn't compile for 2 reasons. And the reason, the most apparent reason right here is that write still doesn't exist. Well, methods can take in as many parameters as you need them to.
Hang on, before you add the other one in, not only that, but something else I wanted to point out that happened the moment you added int left in as a parameter. You'll notice that left that was underlined in red down on the console right line, that underline went away, saying that all is good there. But line 15, where we were invoking add, it looked good just a minute ago, and as soon as Nelson added int left up on line 15, now we have a red squiggly up under add, so it's no longer good.
So, so to address the first issue, we just to make this method signature valid, or this method valid before we worry about invoking it, because like Jason pointed out, we get an error, no overload for method takes 0 arguments. The second I added this, I can add as many of these as I want. So I can go ahead and say int right, for example, and you'll notice line 15 is still erroring out, but line 25 through 28 is not. We've essentially specified that this method is going to take in 2 parameters, and these 2 parameters are going to be assigned to the local variables left and the local variable right, and they're treated just like local variables. So to turn our attention to add, how can we pass in data into it? So if I do a Control-Shift-Space and bring up the method signature, you'll notice the signature has changed since we last saw it. Again, if I were to remove these 2 parameters and do that again, this is the signature as it stands. Void program.add empty parenthesis. However, by adding in these 2 parameters, if I were to do that again, you'll notice it says void program.add, but then inside parentheses it says we need an int left and an int right. Now again, the naming is not important. What's important is we pass in a comma-separated list of values that correspond to the type that the method is accepting. So I could pass in 5 and 2. And the reason I can pass in 5 and 2 is this parameter accepts a value of type integer. 5 is a literal value of type integer, so that's acceptable. This parameter, the second parameter, and we know it's the second parameter because there's a comma right here, accepts another any value of the type integer as well, and 2 is an integer. So now if I were to run this program, we'll see 5 plus 2 equals 7. And we can, and this is where parameters become very, very useful, because now we can reuse this code over and over and over again. It's still adding stuff, but the actual, what actually happens inside the method is being completely changed based off of the parameters we pass in. So it gives our method a lot of flexibility and robustness that it previously wouldn't have. So if I were to hit F5 again, you'll see the results of all these addition operations.
So let's this. Well, let me hang on, Gavin. At this point, let's go ahead and just have everybody take this example and add a multiply, subtract, and divide. I know it's very, very simple. You can just copy and paste. But for those that are, again, truly new to this, let them get their hands dirty for a minute. So go ahead and hit reset on BuzzNet. Did you catch it, Nelson?
Oh, reset BuzzNet.
Yes.
Press.
There we go. Perfect. So go ahead and add, multiply, and subtract, multiply, and divide. And then call each of them and send some numbers in and verify that you are getting the results written out to the console the way you expect. So do it!
Should I be answering questions right now?
Yes, we can answer questions now.
Okay, so...
Yes, subtract, divide, multiply methods.
Okay, so we have a question. Question, when you create a variable, does it stay within that single method or can it be universal? If you create a local variable, like I already answered, if you create a local variable inside of a method, it cannot be accessed by any other method. When naming a method, is there any special naming conventions that we should use? Well, as far as casing, this is the casing you should use. Same casing that you would use with classes and namespace. As far as what the name should be, the name should generally be a verb, and it should be descriptive as to the responsibility of what that method performs. If you find yourself using the word and to describe a method, if you said, this method's name is blah and blah, that is an indication that you should probably have two methods. Okay, so if you specify a parameter, do you have to pass it in for it to work? Yes. Well, we're not going to be talking about optional arguments just yet, optional parameters just yet. In using this syntax, however, there's no way for you not to pass in a value. And I do want to point out some terminology really quickly. I've been referring to these as parameters. Remember that this code is an executable code. It has no meaning, during runtime. It doesn't really do anything. The only code at runtime that does anything is right here on line 22, and then here on lines 12 through 17. When you are defining a method and you are specifying their parameters, these values are called parameters. So int left is a parameter, its name is left and its type is int. Int right is another parameter, name is right and type is int. When you fill a parameter with a value, these are called arguments. This is executable code. Remember, this is not. This is just saying this add method exists. This is saying, let's go ahead and invoke the add method. And when you invoke the add method and open up your parenthesis and provide values into the parameters, these are called arguments. So 5 is an argument and 2 is an argument. And you'll notice how they can change. So that's very important. And in this case, using this syntax, there is a bit of syntax in the C# language that makes it possible to omit arguments or to omit parameters if you want to. But in this case, with this syntax, it is not possible for you to invoke add without specifying two integers. There is a way to add optionals, but we're not talking about that just yet.
Okay, so remember, once you have finished typing this out, which everybody should be pretty darn close to being done because copy, paste, change a couple things. Make sure to click on the little button. The button that says ready. Yeah, and you can convert to floats if you want, or you can leave it as integers. I understand the shortcomings of the integers when doing division, but this is just for example's sake. All right, it's just a couple more of you guys. Almost there.
Would that be mainly used as basically a check to make sure you have all variables for the method? Well, it's the language that we're using right here, or specifically the syntax we're using right here, is specifying that this method in no way can properly perform its operation without having these two values specified. So yeah, it's a way to say this method requires these parameters, and if you do not provide them, then, well, it can't do what
it'll break.
Yeah. I mean, funny enough, there is a unary add operator, but in this case, this is the binary add operator, and there's no way to invoke a binary add operator without two integers.
Segfault won't compile.
Do you know about the unary add operator, Gavin?
What does it do?
Absolutely nothing. You can prefix any variable or any value with plus.
Oh well, yes, of course you
does
can.
Nothing.
But that's only because it's there as an opposite to the minus, which does do something. So actually,
still though, it just doesn't. I don't know why.
It makes your columns line up.
It just looks gross.
Ooh, that's nasty looking. What TF's just posted.
Yeah.
Divide plus minus plus minus plus minus 5.
Okay, so let's go ahead and we've got just a couple of you left. Go ahead and change your status to 1 more minute if you're still working on this, just to make sure we don't have any AFKers. Dun, 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 dun. Find it, find it, find it. 1 more minute. You're about to be considered AFKers. Dun, 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 dun. 3, 2, 1. Up, up,
Nope.
up. Oh, you got it in just in time. Awesome job. Hello, James. Okay, so 1 more minute. Hey, Streeter.
Right.
Just got back from eating stir fry. All right, everybody's with us, so let's go. Go ahead and do this, Nelson. Quick, do it. This is how fast this should have been. Da-da-da-da-da-da-da-da-da-da.
Well, that's wrong for a start.
Derp.
Tract, eyed, and tipli are missing as well.
What?
Tract, eyed, and tipli.
Tract, apply. Oh, I know. Fine.
How long did that take?
But I always do div mul sub. Makes it.
I did something different.
Yeah, no, you're right. The columns lined up better before.
Yeah. Alrighty. So.
Change the calls, Nelson. Yeah.
So demanding.
Yeah. There we go. That's what I was looking for.
Make it work, Nelson.
There we go.
So,
Alright.
so switch over to. Go ahead and take your screen.
Why?
You said you did it differently. How'd
Yeah,
you
but
do
it
it?
works.
Yeah. Go ahead and switch over to. Let me do it real quick. We're gonna switch over to Meta Screen real quick. She said she did it differently.
Sound of Buzz wrestling laptop away from daughter.
That one. Okay.
All right. So she said she did it differently.
So I just did that.
Oh, okay. But do you have a thing against parameters? Parameters are so useful.
I just did that way still. I don't know.
It is working though, so I'll give you that. But you need to put parameters in there. One could argue that this is more flexible because the user can change it.
Yeah, see?
Okay, let's go. Nelson, go ahead and take control back. I heard you behind me say, but mine was different, so I wanted to see. Yes, it is less flexible, Segfault, but not from a complete beginner's point of view. Oh, how easily people forget that.
At least it works.
Exactly, Toastage. Okay.
Yeah, come on, Segfault.
Because a beginner would think, no, because this way you're compiling it with literals in there, 5 and 2. They don't change. The program she had, the user could at least put numbers in that were different.
Well, that was actually, a good thing to do would be
It leads on well to...
to what
Yep.
we can do next.
Yep, let's do it.
Okay, so we have all of these methods that take in values and write them out to the screen. But we are kind of bored about having these literals in our method invocations, these literal arguments. We want the user to be able to edit them. So instead of adding, or what we could do here is we could ask the user for input up here in main. We could say something like int left equals int.parse console read line, and then give it a prompt, of course. And then we can say int.right equals int.parse, and so on. And then we can say add right and left. And then we can say left equals that, right equals that. And then we can say add left, or wow. There we go. Ignore me. Okay, so we could do this.
Mine looks easier.
And this will give us the result we want. We can say add 3 and 3, we get 6. Multiply, or what's the next one? Something. Do something with 4 and 4, we get 0. Do something with 1 and 2, we get 0 again, because they're integers. Add 6, or do something to 6 and 3, we get 6 times 3 equals 18. So this works, but we can do better than that, because what we're doing here is having some very repetitive code. And methods allow us to get rid of repetitive code. But in this case... What? What'd I break?
What was that?
Sorry. I was just going to say, that seems like a lot of typing to do. Surely there must be a way to cut down on the amount of work you have to do.
Yep. And as programmers, that is our goal, to do something that would normally require a lot of work and not very much work. So what we can do is we can make this and turn at least this part for now into a method. But it's not actually... We don't actually want to pass in anything, or we could pass in something, but more specifically, we want to access the results of the method inside of a variable. So that's where what are called returns come in. What I can do is I can say static int get number string prompt. So what I'm doing here is very interesting. I am specifying no longer a void return. I'm specifying an integer return. That means that when you invoke this method, what you'll get back is an integer. Just like how you can do string input equals console.readline. Readline will fill your string input variable with its own result. Well, our getNumber method could also return our own result in the form of an integer. It's also taking in something. We're taking in a string prompt. We want our getNumber prompt to be different for different scenarios. We might want to say, actually fix my code in the first place. Get second number for every item, for example. But you'll notice right off the bat, we're getting an error. We're getting console application 1 program getNumber string, not all code paths return a value. This means that we've specified an int return, but we're not actually passing anything back. Well, what we can do is use the return keyword. And now we've already, I think we have kind of sort of seen the return keyword at some point, sometime, somewhere back in the last few weeks. But in this case, because we have a integer return type, we have to specify the return keyword followed by an integer value. In this case, I'm going to place in the constant of 10. Now, the interesting thing about the way that this works is that when the return keyword is hit and the return value is specified, execution halts. The method no longer gets any execution. If I were to say console.writeLine blah, C# is actually going to tell us unreachable code, because the return statement, it packages up whatever value you specified. It gives it to whoever called to getNumber, but then it no longer processes anything more in the method. So this console.writeLine will never execute because the return is above it. If I were to specify the writeLine above it, then console.writeLine will execute, followed immediately by the return. So what we could do here is, now that we have a method that's returning an integer, the implementation isn't important right now. But just to see how we would use it, we could simply do this. We could say, instead of using variables, we could just pass in the return type right here. So enter number, or enter first, enter second. We could do that. Or we could use variables just like we did before, where we can say int left equals getNumber, enter first, int right equals enter second, and then we can invoke it with left and right. And then we can simply take this code and replace all of our console code with it. So this is actually perfectly equivalent to this down here. What does everybody think that the output of this is going to be? No,
Sorry. I thought I was muted. I even pressed the mute button. I just didn't look at it to see. I was obviously muted before. I'll stop.
Remember the flow of execution here. I'm not going to continue. I'm not going to point out line 12 because line 12 is simply a more concise version of right here. What we have here is we're assigning the left variable to the result of invoking the getNumber method. Then we're assigning the right variable to the result of invoking the getNumber method. And it's not main's responsibility to know exactly what getNumber is going to do. But in this case, getNumber simply returns a constant 10. So if we run this, we will get I hate that. Has anybody ever legitimately used ArrowShake? I didn't think so. Anyway, we get the result of 10 and 10 being used for all of the values. It's not very interesting, and a lot of people did guess this. Some people guessed nothing. Some people said that left and right would be undefined. But this is basically what's happening here, is that we are supplying the value 10 to each one of our methods. So to make this more interesting, we could actually fill getNumber up. And this is the really cool thing about methods. I want to stress this right here, because we can just say return 11 and hit F5. And we now have 11 everywhere. We could say, whatever number we want. We can, because we are writing all of this code in terms of invoking the getNumber method, we've delegated the responsibility of getting a number to another piece of code. We can edit the getNumber method as much as we want, and the behavior will be represented every time it gets invoked. So we can actually correct this code and actually get it to do what we want after we've used it, simply because we can change methods whenever we want, and that will change the behavior of the method whenever it gets invoked. So I'm going to go ahead and actually say something like int, I'm going to say while true, and this will actually point something out else that's interesting. I'm going to actually put in input validation in this case. Actually, just to make this even more. All right, so is everybody good with this code at least? I guess I go ahead and run it and say inner first 43.2, inner first 23.62, 2.4.7.2, and so on. But is everybody comfortable with what's going on here? Because we're actually doing something very interesting here. We are specifying a return in the middle of a loop. So we're entering the loop. This loop will continue indefinitely, but it actually does have an exit condition. If a return happens within a loop, or a nested loop, or a nested loop, or a nested conditional and a nested loop, if a return happens, it's going to completely exit everything and get out of the method entirely. So is everybody kind of good with this code right here? And then I can answer some questions, because I do see some questions have been...
I have a question.
Yes.
Which is, why is it letting you do that in that method? Well, you've only got the return inside an if, which is itself inside a while. So surely you should be getting a not all code paths return.
That's actually a great point. If I did this, then I would get a not all code paths. And the reason I'll get
it's the if that the if should be surely.
Well, see, think about this. The C# compiler knows that this while loop is never going to terminate because it's while true. And it knows that we have a return inside of it.
Because but like normally, just from an if state, even without the while, I would expect to see a.
But that would just mean that it would
return.
But there's no other way to get outside of this loop. If I were to add a break, if I were to say something like break right here, that would introduce a condition where we could actually get out of the while loop, and that would cause an error.
So does it not actually check that until it comes to be getting out, or sort of going through?
Yeah, the rules that it uses to determine if null code paths return a value is very complicated, actually.
Oh, okay.
But it generally gets it right. Okay, so explain line 37. 37 is invoking the try-parse method. The try-parse method is a method that's part of the integer type that will take in a string input. So if you look at the signature, we'll see that it takes in a string, and that string is going to be a numeric string, or possibly a numeric string. Frankly, it could be anything. We could pass in a complete garbage string that has no correlation to an integer. But in this case, what we're doing is we're passing in the input from the user to the try-parse method, and then we're specifying to the try-parse method which integer variable to fill if the parse was successful. Now, if you'll also look at the signature, you'll see that it returns a Boolean value. This Boolean value indicates whether or not the parsing was successful. If it was successful, the Boolean value is true. So that means that if this parse is successful, this evaluates into true, which means this if statement executes, which means number has a value in it that's the result of the successful parse.
And actually that ties in quite nicely to Michael Dale's question at 7 minutes past the hour, which was, can you return more than one value?
Yeah, well, that's definitely...
i.e. both integers we need.
Right, that's a good question. We're not going to be talking about ways in which you can sort of kind of return more than one value. To be honest, well, technically you can't. Technically, there's only one way to return, quote-unquote, a value, and that's with the return type. But there are other mechanisms, like you see right here with the output modifier, that allow us to kind of sort of fake return a value. It allows us to set a variable that is defined outside of the method. And there's another one called ref. Ref and out are two modifiers that perform this operation. We're not going to be talking about how to actually write methods with ref or out, but it is entirely possible for us to if we wanted to. Alan asks, out is or if success input will fill with number. Yes and no. It will actually, what it'll do is it will set number to 0 if the parse was unsuccessful. Otherwise, it'll set it to the correct parse. However, that's not really, you shouldn't, it just doesn't really matter. If the parse is unsuccessful, then the value is irrelevant. But it will set it to the default value of integer, which is 0. Can we output a list? I'm assuming you're talking about, can we use a list as an output parameter, like an entire list? Or are you asking if we could do... Okay. No. You actually can't. And it has to do with the type list itself is a special type called a reference type. And integers are not reference types, they're value types, and only value types can be used on ref and out. But we're not. We're going to be covering the difference between reference types and value types, Jason?
Yes, but
okay.
That's coming up.
We will be covering that difference, but the answer is no. Arrays are also reference types, so you cannot use them as output parameters either.
And with that, we've already had a couple of requests come in. Let's go ahead and take a break. We're at an hour and 4 of recorded, and so we've been, since 7, we've been going on for an hour and 20 minutes now. So I'm going to go ahead and pause the video for those that are watching this later, and everybody feel free to go grab something to drink or whatever you need to do, and see you guys back in 10 minutes.
I do want to point out, though, that I just lied for the last 3 minutes.
Nelly!
I was actually thinking, like, my mind had jumped to, like, a combination of C# references and pointers and other things, and I got really confused for a second. You actually can output in reference types. Because you can with the, for example, try get value and so on.
All right.
Derp.
It's all good, Nelson. All right, guys, let's go ahead and go on break. And we're back. All right, so continuing off, we answered a few questions, and let's go ahead and get the class going again. Oh, there's an interesting one that just came in. There were quite a few questions that happened during the break, but none of them were directly related to the class. But Dave just asked, an F# class? I bet Nelson would love to do an F# class.
Yeah, I mean, I would need some time to get, myself up to speed with that language, but it's definitely a fun language, definitely something that if people here are really into programming, learning a language that is so different from the sort of the imperative nature of languages like C# or C or C++, very beneficial to the way you look at programming.
Yeah.
After the short amount of time I played with F#, it really makes you think about problems differently.
So, Dave, I'd say yeah on that. That'd be a lot of fun, to be honest with you. Okay, so let's go ahead and get back with the class now. And
okay, so we have code on the screen, and okay, so is everybody good with the code on this screen? Is everybody kind of understanding what's going on here? How we've taken the code, the repetitive nature of the code of getting user input, and we've made an abstraction. And what I mean by that, we've identified a pattern that was repeated over and over and over in the code, and we place it into a method that's responsible for performing that action, but we only have to specify the action once. However, this method needs some information in order to make it useful, and it needs to return information in order to make it useful. If it didn't return anything, then we couldn't do anything with the results of this method, and if it didn't take anything, then we couldn't change the prompt that it uses to ask the user for that information. So everybody is good with what's going on here, the way we've abstracted that code out into a method that is responsible for doing a single thing that we can reuse over and over and over again.
okay.
Sweet. Toasters might need an automatic fail for that. Okay, so where to next?
Well, we've got arguments. We've got return types. Now, didn't you, in the Monday night class, you had
Static and void?
Yeah, we're static. We're not going to describe. Void just means it doesn't return anything.
Yeah, I thought that was kind of already covered.
Oh, sorry.
We've talked about local variables and scopes.
Well, yeah, but if you recall, the thing that we talked about, or that we had the students on Monday night class do, was to put together a little calculator that asked the user how they wanted to handle.
Okay. Well, everybody, you guys are going to write a program. You're going to write a program that is wrapped in a loop. First asks the user for which operation that they want to perform, and that's going to be multiplication, division, subtraction, or addition. Nice. So first ask the user for which operation they want to perform, or blank to exit the loop. then asks the user for both operands, left and right, for the operation they selected, then performs the operation and displays it on the screen. Now, it's important that the code that asks the user for the operands needs to be in its own method. The code that performs the so code that gets operands in must be in its own method. The code that performs the operation must be in its own method. But these are going to be different. Instead of having the methods that we have right here that actually print out the result of the operation, we want the methods that perform the operation must return the result of the operation instead of printing it out to the console. Okay, so does anybody have any questions about this prompt? And if you don't, then I'm going to hit the reset ready button and
Do it!
do it.
Do it! Do it now.
Is my reset ready? Not.
You too, Meta. Do it! Reset explode?
Kind of, sort of.
Oh. Everybody.
I just had to refresh.
Oh, well, yeah. Everybody just hit not ready.
Well, no, I did successfully do it, just didn't display on my screen.
It didn't display on my screen either.
So if you refresh your screen, you should see it.
But that means I got to log back in.
Yes.
And people cannot click ready now.
No. Segfault says he cannot click not ready.
Oh, okay.
Well, Segfault, you already actually kind of are not already broke too. All right, just hit F5 and come back in. You know, I swear everything was working just fine before that Blender class. I wonder what Zach did to my code.
Oh. I should have used PHP. Is that your refresh music? Well, BuzzNet work. Tune in next week.
That's BuzzNet music.
All right, I'll refresh just for you, Nelly. All right, I'm going to go ahead and pause the video while everybody's getting this knocked out. Okay, so we're back, and just about everybody's finished. So, Nelson, if you could go ahead and code this out and just leave your instructions up there.
No?
What? Oh, Etner. Sounds like a name, Etner. You should call like your pet Etner. Alrighty.
Very nice.
Yeah, let's go ahead and walk down through it, explain what's happening.
Okay, so we have some code, and it starts off with a while loop, and the while loop has a true for the condition, so it's going to continuously loop until we break out of it. We prompt the user for some input. We retrieve the operation from the user, and then we check to see if they just hit enter. If they just hit enter, we're going to break out of this loop because we're done with the program. Next, we're going to make sure that they entered any one of the valid characters. If they did not, we tell them that they failed, and we continue, meaning we skip the rest of the loop and start all the way at the top again. The next thing that we do is we use our getNumber method to get the left and the right number from the user, providing two separate, well, get first number, get right number. Providing the prompt that the user is going to receive when they get asked for a number. Then we create a result variable, and we initialize it to 0, and I do this for a reason that I'll go over in a moment here. Then we enter a nice little switch switch statement where we switch on if they typed in each one of these individual operations. And depending on the operation that they typed in, we assign result to a separate method invocation. And the method invocation is, again, dependent on the actual operation that they inserted. Finally, we write out the left number, followed by the operation, followed by the right number, followed by the result. So I want to point out for a second why I use this equals 0 here. If I had not done this, the C# compiler would complain on line 52, saying that use of unassigned local variable result. Now, we've already talked about the intelligence of the C# compiler, how it can determine if a method is capable of returning a value, for example. This is another thing that the C# compiler will detect for us. It'll detect if we try to use a variable that has not been initialized to a value. Now, technically, result is currently 0 because the way C# works is it's always going to initialize your types or your variables to the default of their type. And because the int result variable is of type integer, it gets by default set to 0. That being said, the C# compiler is simply not going to allow us to use the value of a variable that hasn't been definitely assigned. Now you might say, well, of course this has been definitely assigned. We make sure that operation is one of these values, and then we switch on it on a case statement, and then we assign it inside of each one of these. Well, the C# compiler doesn't have that level of intelligence. So it's just going to say that the situations that results gets assigned to are conditional based off what operation is. The way C# sees this code is operation might not be one of these four things. If I were to add a default, though, if I were to say default result equals 0 break, at this point result becomes definitely assigned because the C# compiler says, okay, well, he has a default statement there that does assign it to something, so we're just going to say that this is definitely assigned. But in this case, it's not. So I have to initialize it to a value. Okay, so we've hopefully already gone over this code a bit. The get number we've gone over a few times. I modified these 4 methods to simply return the results rather than printing them out to the screen. And then, yeah, so this is basically all the new code. And if anybody has any questions about what I wrote here, feel free to ask them. I did see a few questions. On this example being typed out, can you use something similar to regular expressions for comparison, rather than using 4 separate comparisons in that combined if statement? The answer is yes, but we're not going to.
Yeah, good eye, Leonard. You subtracted twice. 934.
In your, yeah.
I don't know what you guys are talking about.
As Buzz always implements source control just to prove Nelson that had actually typed what he said he didn't.
We don't have the lag. We saw that.
I do want to point out
that's why. Sorry, carry on.
I do want to point out that the Visual Studio Achievements extension was repeatedly crashing my instance of Visual Studio, so I uninstalled it.
That's because you don't program properly.
No, it was just like, well, it tried to give me so many achievements that, you know.
Yeah, all of the you suck achievements.
You're too late for Microsoft.
On a single character input, wouldn't read key be more appropriate? Certainly. We could have used read key. We haven't, I don't think up until this point we've used read key for actually returning in a value. So that's why I kind of avoided it. But in this scenario, I probably would have used read key myself. But we just haven't talked about it yet, so I didn't.
But Nelson, your divide method is really inaccurate. What if I wanted to divide some floats instead of integers? Could I use the same method?
Well, you could, but it wouldn't work right still.
Oh. Was that good? I thought that was good.
Yeah. I mean, as long as...
How was I?
Yeah, I don't think anybody has any questions about this code. I suppose we can switch over to anybody's screen at random and they'll have this exact code just right there. So I guess we can move on to overloading.
Sounds good.
All right. So, like Gavin said, our divide method currently only works with integers.
And this is a useful thing.
Yes.
I was using it today, actually.
You mean overloading just in general?
No, in division, actually. Just before you moved on, but...
Yeah, I've done that as well. And, okay, so... Actually, I'm going to go ahead and yank this. I'm going to open up a new Visual Studio instance and paste it in. Okay. So, divide. Currently only takes in integers, and there's really no way to edit that behavior. So if I wanted to divide 3 by 5, I'll get 0. If I wanted to divide that number by 5, I would get that, and there probably should be a decimal place there, but there isn't. So, I'm not going to divide by 0. Okay, so, C# actually gives us the ability to, and I'm kind of wondering about the time.
Why is that?
It's been so long.
Do you need a quick break, Nelson?
I could use one, and I could leave this code up just in case anybody who said that they actually completely understood it were just saying that.
Okay. Leave it up, and we'll take a quick break. I'll go ahead and pause.
I just wanted to give everyone a cliffhanger on that that method overloading.
Wait, but Toastage needs you to scroll down.
No, he doesn't. He's not even following along.
You could just leave Toastage control of your screen while you go outside.
Yeah.
Just an idea.
You could switch to Toastage's screen. We could get him to draw us a picture during the break.
Yeah, draw me a pony, please. All right, well, I'll be right back.
Okay. Okay, we're back. Say that again, Nelson.
So, anybody have any questions? I have a request to scroll down. So I have scrolled down.
Any questions in the question panel?
Someone says, I get an error on this line, case plus result equals add. Is your add method returning an integer? Because if your add method is not returning an integer, that code won't compile. So make sure that you refactor your add, subtract, divide, and multiply methods to return an integer rather than simply presenting it to the screen. Can you use a return instead of a break in the switch? You can, but it won't have the behavior that you expect. If you were to place a return statement inside of a switch statement, it will work, but it'll exit the method.
Bye, Leonard.
Bye, Leonard.
We are speaking, but yeah.
Speaking.
If you want to exit the method, is it valid? Yes. If you want to exit a method, a return is valid instead of a break. So if I just said return, then there's no situation that would work just fine.
Uh-oh.
Uh-oh.
Switch over to meta screen. She said she's got errors.
Okay. So on those errors, go ahead and just double click on them, and that'll take you to where that's happening. And it looks like you have errors on a different code file inside of your same code, inside of your solution.
You created
Yeah, so here, just a quick thing. You don't have to understand what's happening. Go to the build menu bar at the top. Hit Configuration Manager. And uncheck the build checkmark on the ones that you don't want to build. So that's going to be 1 and I believe 2 as well. And then hit close, and then now try hitting F5.
hey, new error. So double click the very first error.
But you're not building console application 2.
Huh.
Huh. Her VS is acting funny.
Was it definitely number 2 she wants to keep?
Oh, yeah, never mind. Sorry. Well, hold on. Check console application 1, uncheck the other 2. There you go. Derp. And that should make them go away.
Hey,
Sweet.
all right.
Hello.
And thank you for having that problem, because that is something useful to know for me. It says, welcome to the world of marking homework, when you have 83 Program.cs files.
Yeah.
And Visual Studio goes, no, not going to happen.
All right, Nelson, so let's go ahead and switch
Cool.
back over to you. And
my name is Nelson, and I am presenting.
yay, very good, very good.
Yay. Questions, more questions.
Question panel.
Will a return in a try-catch block still execute the finally block? Now, that's beyond the scope of what we're dealing with right now, but the answer to that question is yes. A finally block will always be executed. Does return and break do anything functionally different in the case example? Yes. If I were to say return right here, watch what happens. Let's go ahead and run this program. Keep in mind, I changed the return to break after or
You mean
in
the
the
break to
case of
return?
the addition. The break to return in the case of addition. So let's do subtraction. Okay, let's do multiplication. Okay, now let's do addition. Boom. Program went away. Because I used a return instead of a break, when it hit the return statement, it just bailed. It was like, no, well, basically, we told C#, well, when we reach this code, let's just go ahead and bail out of main and end the program because we don't want the program to run anymore. But by making it a break, that doesn't happen. The return in this case doesn't actually match anything. See, I could have this, and it'll still return out of every single loop.
Prove it.
See? We entered the loop right there, and then when we entered a valid number, we broke out of everything. Sideways mustaches.
Saw that.
Not right.
Okay, so I am about to go away from this code. I'm leaving this code.
Bye-bye, code.
This code is going away. It's going away. Any more questions?
Code is gone.
Okay.
It wanted.
Fail, Nelson.
Oh, boom!
All right, method overloading.
Method overloading. Okay, so we have a problem. Well, not a problem. Actually, the divide one is definitely a good example, but I'm going to do one more example before that. I'm going to do the get number example. Now, we have this awesome get number method. So we can say get number and we can give it a prompt. Say, give me or feed me a number. So that's awesome. We can specify the prompt. But what if we didn't want to specify the prompt? What if we wanted the prompt to default to something else? Well, we could do this. We could say, okay, if you pass in an empty string, we could say if prompt is an empty string, then prompt equals give me number. We could do that, but that's ugly code. C# actually gives us a really nice feature for handling this sort of situation. And that feature is method overloading. Method overloading is useful in two cases. One case that I'm showing you right now where you might want to provide an optional argument, and the other case where the types that your method accepts are fundamentally different. So this is the first case and the easiest to understand case. What if I did this? What would the output of this program be? Anyone? Besides TF or Segfault or Gavin or anybody I know who knows the answer.
Anyone? Anyone?
We have some errors. We have some number feeding. Okay, I'm going to go hit the F5 key. Boom. So actually, it might be cool for everybody to go ahead and write this code out, just to solidify the fact that that we're defining two methods. That is, what is this voodoo? We're defining two methods that are the same name, but we're giving them a different list of parameters. And the C# compiler can now infer, see, previously, if I hadn't had this method here, this would be invalid, simply because it would say that getNumber requires an argument, but you're not providing it. But if we do this, we have two fundamentally different getNumber implementations, one that accepts a single string and one that accepts nothing. So in this case, what's happening here is the C# compiler knows that we are using the method overload that only takes in no parameters. If instead I were to do getNumber, hey there, watch this. So the first thing says feed me a number, put in 3, and the second one that says hey there. So it knows which one of these methods to invoke based off the parameter list. What happens if we do this? Actually, can anybody guess what happens with this code?
Yes.
Yep. What's happening here, if I go ahead and place this alternative implementation of getNumber, we now have a huge problem. We can no longer distinguish which one of these members are appropriate. You'll see this error right here. Console application 2.program already defines a member called getNumber, and then this is the important part, with the same parameter types. So it's seeing that we have the same parameter types for both of these methods, and they have the same name. Therefore, it's an error. What about this? Any guesses? Notice that I changed the return type. This one's an integer, this one returns a double. Okay, so we have some not sures, we have some should works, and we have some errors. In C#, this is not valid. If I were to jump back into the compiler and feed it into the compiler, we would get an error. getNumber still has the same amount of arguments and the same type of arguments as this getNumber. It just differs by return type. Now, funny story, this is actually valid in the CLR, in real.NET, in IL code, intermediate language code, but it's not valid in the C# language. So theoretically, you could write a program in IL that has stuff like this and then try to use it from C#, and I have no idea what would actually happen. I should try that one day. But yes, this is completely invalid code. Okay, and I am going to answer the question about this being bad form in a second. Greg asks, are they two completely different methods, this one and this one? The answer is yes. These are two completely, well, they're related by name only. They are different methods entirely. Now I want to do one more. Okay, is this valid code? Notice how the same return type, the same name, but these parameters have different names. So any guesses? Yep, SAG says it correctly. They're the same type, so error. Operator overloading only works when the types of the parameters or the amount of parameters are different. So if I were to define another getMember method that took in another string but simply had a different variable name or parameter name, we would get an error.
And presumably this comes down to what you were saying earlier about the fact that, like, for instance, line 18 isn't actually executed code, whatever you call it. I can't remember what you call it.
Yeah, it's not code that's ever executed, or really, it has no meaning at runtime.
Yeah,
It's only used to define something. It's not actually ever executed. That's not true for all languages. Many dynamic languages, your method definitions are more or less executable code, but that gets into really weird scenarios. Cough, Ruby, cough. Okay. So
you never fixed my divide method.
yes, I didn't. And I quickly want to say about why this is not bad form, because that brings us to the divide method. This is not bad form because these methods do the exact same thing. It's just one method does not take in a parameter. It simply provides a default argument to the method that does take a parameter. Now, that's one situation that you would want to use overloading. Another situation you might want to use overloading is where you have the exact same method, but you want to provide different types for the parameters. Furthermore, you want to provide different return types for the return type. We'll get into generics after this example, Segfault. Anyway, so that was a joke, by the way, if nobody. Anyway, so we have this method called divide that takes in different types. It takes in the same amount of parameters, and it even has a different return type, but the parameter types are different. And because the parameter types are different, this is a completely valid overload. So watch what happens. I'm going to move these guys up above the getNumber example. Stop. I don't want to feed you numbers. Okay, so we get 0. And the reason why we get 0 is integers are not capable of understanding decimal points, but doubles are. So are there any guesses how I can get this code to execute the method that's defined on line 17 instead of the line that's defined on 22?
Nice question.
It's been covered.
Actually, I think everybody pretty much got that right. Except for Toastage, of course.
Of course. Is there, see, I have choice. Out of those, I would probably go with 3D and 5D. But is that's just purely, subjective preference? Presumably there's no impact at all.
No. The two alternatives that we're talking about here is some people said 3D and 5D. Other people said 3.0 and 5.0. These accomplish the exact same thing. And I prefer this because I think it looks nicer. But there's no difference between these two as far as performance or any other consideration. So if I go ahead and add these, so we're doing...
And just to, I was going to say, you can presumably give one of each
yes.
int and double to your method, and it will still correctly choose.
Yep. Yeah. So if we run this, I'll show that in a second here, because that's a good point. But I did want to just show everybody that this does work as expected. Because we have 3, 5, which are integers, 3D, 5D, which are doubles, and this invokes the correct overload. And then these two, 3.0 and 5.0, which are both doubles. And Gavin pointed out that you could also do 3 and 5D and 3D and 5, and you'll get the correct overload. And the reason why you get the correct overload is that the way overloading works in C# is it really tries to make the best use of the parameters you pass in. It knows that if you pass in a double as one of these, it'll implicitly convert this into a double because it realizes that it could lose some information if it doesn't do that. If the C# compiler instead invoked the int method, there's a potential that you would lose some data because an integer cannot hold the same kinds of data as a double.
Did you spot what Darth Gregg said in BuzzNet?
Yeah, he asked.
That's a key thing.
This isn't valid, just as far as syntax goes. However, what you might have been trying to show is this. Is this the syntax you were trying to show a cast? Okay. This syntax actually will not affect this whatsoever. And the reason it doesn't affect it is because this cast happens after the divide method has been invoked. So the divide method becomes invoked, and this is all the C# compiler sees. All it sees is divide 3 and 5. That's all it sees. Then it takes the result of that method invocation, which in this case is 0, and then converts that into a double. So they're two completely different operations.
If you absolutely were determined to use casting, you could actually put the cast inside.
Oh, yeah, you could do this. That would be
not
valid.
that you'd ever want to, but
yeah, it's ugly compared to the D suffix. Well, somebody pointed out if we had a float overload, which again is perfectly valid. Now, in this case, this will still work because this is simply going to use the double overload because these both are doubles. However, if I were to delete the divide overload that takes in doubles, watch what happens. Any guesses as to what's going to happen when I remove this method?
Unity will automatically load.
That would be impressive.
Oh, it bugs me. I don't see why they did it.
Okay, we got some nothings, implicit casting to floats. Okay.
Can I slap Segfault?
Yes.
Segfault, you're slapped. That's a stupid thing to say, and you know it. Are you playing poker?
Single Segfault. Precision.
So what happens here is I removed the double overload, and so now, and I introduced a float overload, or a float overload. And what's happening here, the int overload is still working properly, but now all of these are invalid, simply because all of these are doubles. So I'm going to have to add the F suffix instead of the D suffix to get these to work. So now everything works as expected. Any guesses as to what will happen if I uncomment this method out and then I comment this method out? So any guesses as to what will happen if I swap these two? If I take this and put it back into play, and if I remove this?
There we go. Sorry, I heard the sound of a penny dropping.
All right, let's see what happens.
Seems like Segfault's kind of got his act together now.
Boom. Same result. What's happening here is that, what's happening here is that the C# compiler or the runtime or whoever is responsible for this, depending on different optimizations, is going to implicitly convert these values into doubles because a float has less precision than a double. Because a float has less precision than a double, a float can be implicitly converted into a double. Because these can be implicitly converted into a double, but not implicitly converted well, they still can sort of be, but the best match in this case would be to a double. A float to a double conversion is preferable to a float to an integer conversion. Exactly. If I were to say, if I were to change the suffix to m, I would get an error. Because the decimal data type doesn't have has way more precision than the double data type.
Actually, that's never occurred to me. Is there such a thing as a triple?
No. There's a quadruple, but that's a decimal.
There's a big int.
Yeah.
Big int.
Okay, so any more questions about operator overloading? Method overloading. I didn't say operator overloading.
I didn't hear operator overloading.
Actually, Segfault was the one who said operator overloading, and then I just corrected him to method overloading.
If only someone was recording this.
Yeah. Wish I would have hit start after the last break.
Isaac, did you?
See, now you don't want to be joking about that. It's called tempting fate.
That's pretty funny. All the attitudes go from joking to seriousness. Did you? You don't want to be joking.
Did you
about
press
that.
save? It is that. It's like when Nelson's redoing the server. I can't speak to him because I daren't be the reason that he deletes 3D Buzz from existence.
Yeah, that'd be bad.
I did that once.
Yeah, you did. I thought it was pretty funny. You just about had complete spasms.
Actually, sorry, yeah, we're... so what, is that it for overloading?
Well, we did
Can't
actually
think
have
of anything else.
We did have a question. Why create overloads for double and float if one decimal overload will work? Well, that's a good question.
Memory, I'd guess.
Well, watch this. If you really want a float, then you can't have it unless you have a float overload. See, in this case, this method returns a double. Even if I supply floats, it's still going to return a double. If I uncomment this overload out, though, now it's going to be using the float overload, meaning it's going to return it in the same precision. And if you wanted to have the capability of working with both floats, doubles, and decimals at the same time, then you would have to create 3 overloads so that you can specify 3 different return values. Does that make sense? Sweet.
I always think the comparison between int and any of the decimal types is clearer because of the concatenation. You can see a concrete reason straight away where it can be useful to have things happen in integer space.
Is it possible to define it in such a way that it'll return the same type that's passed in? Please, Jason. I don't think we had enough mind blowing up edge this class.
All right, fine. Just this once. Beginners just don't pay attention.
You're going to show us a magic trick, Nelson?
The answer is yes.
Now, we can't perform a mathematical operation, sadly, because of the way that this works. But this method will return the same thing that you pass into it. Meaning if I did int stuff equals stuff 1, 1, this is valid. If I did int stuff or float stuff equals 1f and 1f, this is also valid. For the most part.
Except you're saying that wouldn't work because
there we go.
You can't. What will it bring back then?
It'll bring back a float. Because of the way implicit generics and stuff.
But you just said you can't do math operations in there.
No, you couldn't because of the way generics work.
So what will it give you back then?
It'll give you back the default of whatever you passed.
Oh, sorry, I wasn't
it's kind of a
looking. I was assuming that you had the same return.
Yeah, but any type,
left, over, right.
Any type will work. I just wanted to throw that out because Segfault's been bugging me about generics for the last few classes.
Yeah.
Okay, so any questions about overloading?
Dosage. Well, the homework that you guys have will be very easy this week. So if you want to go ahead and talk about that, Nelson.
Yeah, homework. So basically, in the last homework, you guys built a program, a working game, that did have a lot of code in it in the single main method. And now that you guys know about creating alternate methods or additional methods, I just want to get you guys to think about the different ways that you can use methods to make your code shorter, more concise, or more readable. So simply refactor your previous homework into something that uses methods with the goal of making it more readable or more compact.
Clean and short and tidy.
Yes. And if you guys don't know what the word refactor is, because I remember I had to define it in the last class, refactor is simply the process of altering code in such a way that the program doesn't change as far as its input and output, but that the code performs differently, either as far as performance goes or as far as readability or maintainability.
Can I make a quick suggestion? As a very brief demo.
Yeah.
That main method's got an awful lot of write lines in it, but they all do roughly the same thing, which is some maths. So what if you wanted to put all of those in a method called lots of maths? Hello?
Yeah.
Just as an example of what you mean by refactoring.
Yeah. Or do you mean just, okay, so...
I was just thinking, just grab all of them and...
So that's an example of refactoring. I didn't change the input or output of the program, but I moved things around for some sort of goal. I just wanted to emphasize the lack of a particular character at the end of that word, TF.
That's funny.
Both of you need to go away.
Okay, so really that's it. Very straightforward. And to answer your question, TF, from a few minutes ago, if you've already submitted the homework last week that was in the format we're looking for now, you do get a week off, but Gavin would like for you to submit it one more time, indicating that it's this week's homework.
Yes, please.
It just will make life a lot easier for him.
And submit properly, yeah. I suppose I could give people the same little talk.
Yeah.
Can you just show them, Nelson, in your own inimitable style about renaming their class and sorting out namespace?
Oh, just
How to submit homework properly.
yeah. What was the format again?
Well, we're looking for... You've got
Is it-
Firefox, haven't you? Hang on, I haven't got Firefox.
Was it username _ week? Like that?
Yep, that's right. But of course, that's not your username, is it, Nelson?
No, because my username, obviously, this is my username on the site. Now, that's going to be an issue because I have a space and special characters, so be sure to take out your spaces and special characters to make it work. And then change the name of your program as well, I believe, right, Gav?
Yep, and yes,
And the
obviously
files.
that as well.
And the file. So we have the file, the namespace, and the main type. And again, remember just to, of course, it doesn't have an open Windows Explorer. Because, oh, of
Does
course,
it not?
I think it might now. No, it doesn't. It's being stupid. Okay. You want your CS file. You want to submit your CS file. Not the CS proj, not the slin, not the su, just the CS.
And also,
Does everybody...
do you want to spend just a second and talk about Reclaimer says homework 3 results, what we discussed Monday in class? Gavin?
Yeah, I get confused as to which week is what. Homework 3
No, just about
is
the in general with so many students between the two classes that if personal feedback was to be given on every single one.
Oh, yeah, I mean, there's quite a lot of people doing this class and the Blender class. We're going to be having all these other classes starting soon. It simply isn't possible. I mean, that's what the open office hours are for, is if you're having problems. And we did spend quite a lot of time yesterday with a number of people ironing out problems they had.
Or just looking at their code and giving them feedback.
And just, giving feedback on what they could maybe tweak. That's the time for that. If there's something that bugging, or just generally about that's come up while you've been trying to do it a certain way and it hasn't worked, that's what the open office hours are there for. Take advantage of them. You'll only really get as much out of those as the people who are there and asking questions.
But if you fail your homework,
and sharing their screen,
if you just downright fail it or do something absolutely horrible, then you'll get notified.
Yeah. Keep an eye on your PMs. Is all I can say on that front. I will get in touch with people, but that again, it won't happen until everything's marked, and I'll do that because I do it all together in a batch.
Yes.
We put the deadline back. Some of you may have submitted your homework and forgotten about it and not have noticed, but the deadline was the beginning of tonight's class because of the video troubles we had with the and so forth, people not being able to watch the video. So I haven't even started looking at those yet.
Yeah, because it wasn't possible.
It's only just due. Yep.
There was a quick question that came in. Do we have to declare public variables like in Unity 3D? I kind of want to see people not use fields for the homework, just use methods. Because fields, in the context that you guys might be using them, in this case, would be closer to what would be in other languages considered globals. And happy birthday, buddy, Lindsay. So you wouldn't necessarily want to do that because, generally speaking, you would want to encapsulate your methods in such a way that they don't require the knowledge of external state to function. So I hope that answered your question.
All right. Well, with that, let's go ahead and wrap tonight's class up. I know we've got people that are anxious to go to bed that are overseas. Thank you guys for hanging out with us, though. And next week, kicks off week 5, getting close. So, yeah, thank you guys again for joining us, and we will probably be seeing some of you guys in the Blender class come Saturday. So, have a good night, and if not, we'll see you guys next week. This is a real quick TF. This C# 101 is a 6-week class. The C++ 101 is going to be an 8-week class. So, there you go. All right, good night, guys. Have a good one.
Goodbye.
Bye.